This presentation showcases how KeySQL technology solves one of today's problems in data analytics. Organizations collect massive amounts of JSON data. However, this data is rarely included in analytics, as analysts lack suitable tools or programming expertise. We show how an analyst with basic SQL skills can be highly productive with JSON data. These examples are based on a sample JSON dataset that is popular in the MongoDB world. What is KeySQL? KeySQL is a universal database for non-flat data with SQL-like statements such as insert, select, update, and delete. KeySQL enables a productivity breakthrough in handling of non-flat NoSQL data. It employs a keyobject data model that dramatically simplifies data modeling and maintenance. NoSQL data is accessible to data analysts and data scientists without dependence on Java, Python, or other programmers. The KeySQL platform is built for the cloud and supports a variety of client applications. KeySQL Server is a high-performance, parallel, and scalable transactional engine supporting the keyobject data model and is written in C++. KeySQL Studio is a web application providing a user interface for interaction with KeySQL Server. KeySQL technology includes Java and Python software developer toolkits and REST API. The Studio web application runs in all popular browsers. It provides an elegant user interface for analyst and administrator interaction with KeySQL Server. Studio's import function makes for easy loading of JSON, XML, and CSV data. There is no need to predefine data structures before import or to perform ETL. If Mongo data resides in the MongoDB Atlas cluster, a direct import of MongoDB JSON documents is possible. MongoDB developers will recognize the sales data sheet used in our presentation. As you watch this demonstration, please consider whether the analytics we present are currently feasible for you without resorting to complex programming. Here, you see KeySQL Studio ready to import the MongoDB sales collection, which contains 5,000 JSON documents. We click on Menu Item Tools, followed by MongoDB. Selection of the MongoDB menu choice reveals the Import Mongo pane, as we see here, split in two for easy viewing. We accept the radio button choice, create key objects, and load data. This choice directs Studio to scan the MongoDB collection, create catalog key objects matching the JSON document elements, and finally, to load the JSON data into a KeySQL store. The import begins when we click the Import button at the top left. Upon completion of the import, Studio displays the catalog of key objects. In the query area, we type a KeySQL select statement and click the Execute button to submit this query to KeySQL Server. In the query results area, you can see a sale instance returned by the server. We now focus on this instance. Note the blue dots surrounded by a pair of blue braces. Clicking here does a drill down, expanding display of this instance. We have drilled down into the first level of detail for this instance. You can see that a Seattle sale was done online on September 8, 2014. Now we drill down further. Clicking the ellipses to the right of customer reveals the key objects within customer, such as satisfaction. Let us now drill down into item molt. Expanding item molt reveals that this cell includes 6 items. Molt is an abbreviation for the word multiple and means a data construct that holds multiple members, as seen here. Let's drill down into the first item. KeySQL can preserve the original order of elements within JSON arrays. You can see that the first item of the array has an index value of 0. Let's drill yet further into the item detail, which shows that a carton of pens was sold for $10.80. Note that within the item, there is yet another molt, tag_molt. This data structure is moderately complex. With both relational and document databases, a substantial data engineering effort would be required. Prior to this point, we have demonstrated how KeySQL Studio can import complex data in a single step. Now, we explain what happens behind the curtain. We do this by constructing the catalog and store from scratch. A catalog is a namespace that ensures uniqueness of key object names. We create a catalog and then Create key objects that reside in the catalog. A key object is a data definition for the key object instances that represent the data itself. We create a data store for the catalog, and then insert key object instances into the store. KeySQL statements, such as the create catalog statement shown here, can be typed in. Alternatively, you can use Studio's drag-and-drop editor to guide you through the creation of a catalog, its key objects, and the store that will hold key object instances. We now show KeySQL statements generated by Studio. We work bottom-up, starting from the elementary key object's price, quantity, and name. We then create a composite key object named item, which comprises these elementary key objects. Given that a sale may contain several items, we need to create item mult that comprises multiple occurrences of key object item. We call this multi-composition. Using composition and multi-composition, a structure of any complexity can be built. The implication is that KeySQL is compatible with both traditional tabular, that is, relational data, and today's more complex JSON and XML. Now that you have seen the statements for creating the catalog and populating it with key objects, we'll show the statements for creating the store and inserting data into it. We first create the sales store for the catalog. We then insert data into sales store using the insert instances statement. On the left, you can see Studio Explorer, displaying the newly created sales store. And on the right, you can see the select statement returning the instance data we just inserted. We now show examples that should look familiar to SQL users. We begin with a simple query. Note how we switched from the default list view to the column view, a compact format that is handy for comparing instances side by side. We now click the Collapse Expand Results button to expand the results all at once. The select lists the email address found within the customer composite and the product name found within the item multi-composition. KeySQL uses a hash sign convention to show a list of multiple values, namely the list of product names in each customer sale. Here, we show a join query with its results. KeySQL provides a SQL-like join that operates on non-flat data found in document databases, such as MongoDB. For flat data, a KeySQL join returns the same results as SQL. For this example, a second KeySQL data store called Facility Store was created to provide descriptive details about a location. Assume we used Studio's import to create this store. Here is an example of using an insert select statement to copy the results of a select to a new store. We create the store, then execute the insert select statement. KeySQL reduces complexity. Should the internal structure of the customer composite change, the query remains the same. Here we see how essential metrics are calculated, grouped by store location. The top sale, in order by item count, took place in Denver. KeySQL provides group by along with standard SQL aggregate functions such as count and max. The group by functions are extended to work with complex data, including the multi-composition. Note how count item is transformed to a more meaningful name by use of $CNT products. The leading $sign declares what we call an ad hoc key object, essentially a temporary variable. Let's now step back and consider the productivity using KeySQL relative to typical database technologies. With typical technologies, there is an initial step where a data engineer must be engaged to programmatically break up each document and copy the pieces into 3 tables: customer, item order, item detail. Only then can an analyst begin to examine the data. However, this requires stitching the data back together again, writing queries across 3 tables. Both efforts are unnecessary with KeySQL. In the prior example, we used a group by to calculate metrics across all 5,000 instances in the data store. In this example, we use group by to calculate metrics for individual instances. Note how we group by _ID and then email. The key object _ID is the unique MongoDB instance ID. This example illustrates how a single statement can deliver powerful analytics. It returns a list of customer emails by item sold. For the sake of brevity in showing results, the query is limited to a single store location and the month of September of 2014. This could be useful for doing a marketing upsell or a product recall. Let's take a closer look at the fourth instance. To better understand this example, we show the result for pens side by side with the catalog. Across all instances in this store, for each item found in the item_mold, the query returns a list of emails of customers who ordered this item. In addition, the count of emails is returned. Studio facilitates sharing your results. The output in the results area is initially shown in KeySQL's default display format. However, you can choose CSV for export to business intelligence tools such as Tableau, Excel, and Power BI. And you can choose JSON or XML for data exchange with other systems. We revisit a query shown earlier, whose results are in a simple tabular format, amenable for sharing as a CSV file. You can see that the data format dropdown has been changed to CSV. The table view shows the automatically generated header row. By clicking the To File checkbox, we can write the results to a file. Data from KeySQL Server can be further analyzed and visualized with Power BI, Tableau, Excel, and other popular business intelligence applications. The easiest way to access KeySQL data is for your favorite BI tool to make a direct connection to the KeySQL REST API. The donut chart shown here is provided by Microsoft's Power BI. Adoption of KeySQL technology can deliver organization-wide productivity gains. Here's a short list of how productivity is enhanced. Business and data analysts can manage non-flat NoSQL data without the help of programmers. Data scientists and engineers can focus on project work, as analysts need less support. JSON and XML import does not need prior data modeling and is essentially point and click. Aggregations and joins spanning NoSQL and SQL data are made easy. BI reporting on NoSQL data can be accomplished without ETL or RDBMS staging. SQL users can grasp the bulk of KeySQL in just a couple of days. This presentation touched upon only a few features of KeySQL Server and Studio. Please visit our website to learn more about KeySQL and to request a trial account.